Hi. In this video, we're going to look at another example of inelastic collisions where two objects collide and stick together. At a train routing station, an 11,500 kilogram train engine travels at 1.15 meters per second toward an empty 7,500 kilogram train car, moving at 0.84 meters per second in the opposite direction. The train engine collides with the train car and they couple together while continuing to roll along the tracks. What is their after collision velocity? Assume no friction. So I've done an important step of already drawing the before and after sketch here, and sometimes that can be a little tricky to figure out what to label and what direction to go in. You have to choose a direction in this case. It didn't say to the right or to the left, so I chose it did say opposite directions in here in the word problem, and so I chose the train engine to be moving to the right and the empty train car moving to the left. It doesn't matter which one you choose because at the end you'll still get the same answer. It might just be negative versus positive, and you'll just have to explain what that negative sign would mean or the positive sign means. To make things simpler too, I'm going to go ahead and label these train cars. I'm going to label this one 1 and this one 2, just to keep it simple. And then I'm going to assume that there's no friction. And so this system right here of the two train cars is an isolated system, which means that the momentum should be the same before and after the collision. We shouldn't lose any momentum because it should stay conserved. So the total initial momentum is equal to the total final momentum. To find the total initial momentum, we're just going to do the mass times velocity of the first cart initially, plus the mass times velocity of the second cart initially. And then at the end here, they couple together, it says, and so they're stuck together. They're considered now sort of one object. And so to find the momentum of this object, we're going to count their mass as one big object together times their velocity as one big object together. So they're one mass together. I'm going to label it m1 plus 2 times their velocity 1 plus 2. Okay, so now I'm ready to substitute in the numbers from the word problem here. The first train cart is 11,500 kilograms of mass, and it was moving at 1.15 meters per second. Plus mass 2 is 7,500 kilograms times 0.84 meters per second. And then the mass of the two cars together, I'm going to add 11,500 kilograms plus 7,500 kilograms. And I'm going to multiply by the velocity of both carts together. Now, I made a mistake in what I just wrote down. Did you catch the mistake? Remember that velocity is a vector, and so we always include both the amount of velocity, but also the direction. So I left out the direction for one of my velocities. If you look back at the picture I drew, this velocity is positive 1.15 meters per second. But train car 2's velocity is negative 0.84. It's moving in the opposite direction. And so when I label my velocity down here, I need to include a negative sign to show that this velocity is not just 0.84, but it is negative 0.84. So now with that in place, we're ready to start multiplying. We're going to need a calculator for this one. So 11,500 times 1.15 is 13,225. Looks like we have three significant figures here, so we're going to do 13,200 kilograms times meters per second. And then 7,500 times 0.84 is 6,300, and that's negative, so it's going to be minus 6,300 kilograms. times meters per second. And then that will be equal to our total mass of the two cars together, which is 19,000 kilograms. And that's multiplied by the velocity of both carts together. So now we're going to do this subtraction problem here. 13,200 minus 6,300. And so we have 6,900 kilograms times meters per second. And that's equal to 19,000 kilograms multiplied by the combined velocity. So now I'm going to divide to solve for my velocity. I need to undo this division over here. And I need to do that to both sides to keep it equal. So the kilograms cancel. Then I do 6,900 divided by 19,000. It's going to be a low number. It's a slow speed, 0.36 for our velocity. So that's 0.36 meters per second. Now, does this value make sense for it to be so low? And I think it does, because we were traveling at pretty low speeds before, but then they collide and their momenta kind of balance each other out somewhat. But we have a leftover momentum moving at a velocity of 0.36 meters per second to the right. So I think that that's a good value there. I think it looks like we've done this correctly. So that's all I've got for you in this video. Remember, how you do anything is how you do everything.